Alright guys, welcome back. So in today's video we have another equation to solve, and we have 2 to the x is equal to x, and we need to solve this equation for x knowing that our x belongs to real numbers. So we are seeing the x in the exponent of this equation. The first thing is going with a logarithm or natural log on each side of the equation in order to get rid of that exponent. So let's do that. And from the laws of the logarithm or natural log, we know if we have ln of a to the power of b, we know this power can go in the back of the ln, so it will be b times ln of a. So if we do the natural log on each side of the equation, we'll have ln of 2 to the x is equal to ln of x. So this x can go in the back. So we get x ln of 2 is equal to ln of x. And here we can divide each side by x, knowing that the x is definitely not 0. And if you look at the equation, if we put 0 in here, we'll have 2 to the 0 is equal to 0, which will be 1 on the left side, 0 on the right side. So 0 definitely doesn't work. So we're going to divide each side, and that's what we have in here. We can cancel out the x on the left side, and basically we have ln of 2 is equal to ln of x over x. So looking at this, it looks like that we can get some help from Lambert W function for solving this one. We covered a few videos in this channel using the Lambert W function to solve these kind of questions, but let's just go quickly over the Lambert W function. And if we have the f of x times e to the x, so technically the inverse function would be our wx, or what we call Lambert W function. So the nature of w or Lambert W function is inverse of this function over here. So if you want to show the graph of these two, so basically we're finding, let's call this y and this will be our x. If we want to draw the plot of f, we will get something like this. And if we want to find the coordinates, if here we have -1 in here, and here we will have f of -1, which will be -1 times e to the -1, which will be -1 over e. So we have 1 over e here. And if we want to find the w function or the inverse function, we just have to draw the line of y is equal to x, and what we get in here, this will be our, and this would be our wx, or the inverse function of. So in here, this will be -1 would be the point for the wx, and over here we have -1 over e, which is basically our x and y is switched. So the reason I brought this up is that I want to go over the domain and range of Lambert function in order to figure out what real numbers we get. So the dotted line that I have for the wx function is the complex answer that we have for wx or Lambert W function, and what we have for the domain of Lambert W function is basically from -1 over e to infinity, and the range would be from -1 to infinity. And if you want to show the domain and the range for the f of x, or what I showed in blue in here, basically the domain would be from -1 to infinity, and the range would be, as we can see, from -1 over e to infinity. As we can see, the range of fx is the domain of Lambert W function or the inverse function, and the domain of f is the range. So since the question is asking for finding the real numbers, we have to keep in mind that this is our domain for finding the answer for this equation. So at the end of the day, whatever answer that we get out of this range, it will be a complex answer, which is not what we are looking for in this question. So keep that in mind. Let's get back to our question, and that was just a note about Lambert W function that is very useful. So let's get back. So we end up with this over here. So ln of 2 is equal to ln of x over x. And from the laws of the logarithm, we know when we have e to the power of ln of x, this will be equal to x. So that's what we're going to do in here instead of in our denominator. So we have ln of 2 is equal to ln of x over e to the ln of x instead of our x. When we know when we have 1 over a, this will be equal to a to the power of minus 1. So basically in here, we're going to use that in here to get rid of the denominator that we have. So ln of 2 is equal to ln of x times e to the power of minus ln of x. And this is getting interesting because now we have this expression or our x in here, and all we missed in here is just a minus 1 in order to build that x times e to the x. So we're just gonna multiply this by minus 1. So minus ln of 2 is equal to minus ln of x times e to the minus ln of x. So now we can do the Lambert W function. On each side we get Lambert W function of minus ln of 2 is equal to W function of minus ln of x times e to the minus ln of x. So on the right side basically we have minus ln of x and we have Lambert W function of minus ln of 2. So if we just multiply minus 1 in this equation, we get minus Lambert W function of minus ln of 2 is equal to ln of x. We're going to do the base of e on each side of the equation. So on the left side we'll have e to the power of minus a Lambert W function of minus ln of 2, and on the right side we have e to the power of ln of x. The reason we are doing the base of e on each side is to get something like in here to get out of our ln. So basically on the right side we can use what we talked about earlier. So e to the power of minus Lambert W function of minus ln of 2 is equal to x. So here looking at this, we can see that we know that ln of 2 is around 0.7. So if we calculate the ln of 2, we know that the ln of 2 is something around 0.7. And what we have in here, basically we have our x is equal to e to the power of minus Lambert W function minus ln of 2, which we know that this is something around minus 0.7, meaning that we have to go over the domain of the Lambert W function. And if we get back in here and look at the domain of a Lambert W function, we have from minus 1 over e, we know our e is around 2.7. So minus 1 over e is, so this will be something around 0.37. So the range that we have for the domain of the Lambert W function is from basically minus 1 over e to infinity, and this will be something around minus 0.37. And looking at this, we have minus 0.7, which is out of this range, and that shows that this equation doesn't have any real numbers. So there is no real answers for this question if you want to solve it, and we're going to end up with complex answers for finding this equation. The main purpose of this question was, so we've used Lambert W function multiple times in the channel for finding some equations, and it's actually very helpful, but we have to be mindful of the domain of the Lambert W function as I explained in here. And yeah, let me know if you guys find the complex answers for this one in the comment section, and you guys take care. I'll see you in the next video. Have a good one.